one of the biggest problems I have with students who are older than you is they go, oh my God, that's just weird. And they just stop. They just stop thinking. So today's physics, and what we're going to look at physics today, is free body diagrams. And apart from, there's an N in there, that shouldn't be there, free body diagrams, there we go. And they're an easy way, so you can read lots of things about it, and there's words like weight and force, everything that you start getting used to hearing. But free body diagrams is a really easy way of drawing something. And what I mean by that is I'm going to start with the classic, a book on a table. All right. And if this to me, is a free body diagram, but it's too complicated. It's too much. And one of the problems in physics is when students are given a question, they don't draw it out. And we want a very easy way of drawing things out. So can you imagine trying to draw a book and a table out? It's just too much. So we either use a rectangle or a circle, it's your choice, to represent something. And that can be a car, a ball, an aeroplane. It really doesn't matter. All right. But I'm going to use a rectangle because it looks like a book. All right. So here's my rectangle. If I want to draw a table, I just draw a straight line underneath it, and that is it. I am done. Okay. So if you look at this diagram, the weight of the book is straight down. And all we do is draw an arrow straight down. Okay. This is its weight. Weight is a force because if, unfortunately, I stand on your foot, you'll feel a force in your foot. And the units are newtons. You're going to get used to this. It doesn't matter. You know, you're year 7. Just let's get used to talking about it and get used to drawing diagrams. The one thing I will say is normal people think weight is in kilograms. That is not. That is okay if you're having a chat with your friend. Kilograms is mass. But in physics, this is where I've said it a lot. Physics is a language. Science is a language. It may sound like English. It is not. So I'm talking about weight, and weight is newtons. This book is not moving. All right. So the table, which sounds really weird, is pushing back upwards. It's called the normal. And this is, apart from my little kink, these two arrows are the same size, but in opposite directions. You don't have to be exact, but pretty close. So the arrows are the same size and in opposite directions. Right. So today, what you're looking at really is just drawing the diagrams and what the words mean. And this upwards is called the normal force. So you have the weight of the book downwards and you have the normal force. Okie dokie. So now that I've done that diagram to show you the forces on a book, this is what I call we call a free body diagram. It is really easy to draw. I'm just going to talk about the normal force. The normal force is at 90 degrees, right? Let me change colour. 90 degrees. Let me do pink. Now, you should have done that in maths at some point. If you haven't, that's 90 degrees. The other word you will hear for that, let's just label this. This is 90 degrees. But there's a really horrible word that we use in maths especially. It is perpendicular. And again, I don't care if you remember this, I don't care if you can spell it, I don't care if you use it. It's just me getting you used to the language of science. So it's 90 degrees. Your contact force is always 90 degrees, not to the earth.